means multiply. Every time you see this, you multiply. A negative times a negative equals a positive. A negative times a negative equals a positive. Say it. A negative times a negative equals a positive. Say it. A negative times a negative equals a positive. Again. A negative times a negative equals a positive. A negative times a negative equals a positive. I can't hear you.
A negative times a negative equals a positive.
Louder. A negative times a negative equals a positive. Louder. A negative times a negative equals a positive. Why?
That was Stand and Deliver, one of the most memorable movies that I've seen. And it talks about a teacher, I think he was from Eastern European countries, and came to LA and teach some kids, urban kids, math, and brought them all the way to calculus. It was a very touching movie. I hope we'll get a chance to watch it this year. Okay, so in 2.4, we're going to study vertical angles. I really like vertical angles because they're easy and it gives me a lot of information to help me solve problems. So first of all, we have to understand what are vertical angles. Vertical angles are not adjacent, meaning they're not next to each other. In fact, they're opposite to each other, and their sides are formed by two intersecting lines. The easiest way to remember vertical angles is that I call them scissor angles. So if you look at it, there is a pair of scissors here, and it really is two lines. It almost forms an X, right? So with these two lines, I have angle 1 here and angle 2 here. And then if I use a different color, over here is angle 3, and at the bottom is angle 4. So if you look at angle 1 and angle 2, they're not adjacent, and then their sides are formed by two intersecting lines. So they don't share the same sides. They're direct opposite of each other. And so those two are a pair of vertical angles. And for the same reason, angle 3 and angle 4, they're opposite of each other. They're not adjacent, and their sides are formed by two intersecting lines too. So that's another pair of vertical angles. Linear pair. Linear pair are adjacent angles. So, and more importantly, their non-common sides are on the same line. So what does that mean? If you look at angle 1 and angle 3 together, angle 1 is the red part here. It's between these two lines, right? And angle 3 is this black line and that black line. And they have one side in common. You see the red and the black merge. They merge together here. But then there's one side here, that's the red, and then there's the black side on the other side. They're not the common sides. But notice that they form one straight line. If I use a third color, blue, they form one straight line there. So in other words, angle 1 and angle 3, I add them together, is 180 degrees. They have a straight line. And those pairs of angles are called linear pair. And another linear pair is, if I look at angle 2, I would have angle 4. Together, these two angles form 180 degrees. Okay? Notice that when I talk about angles, that's how I wrote angles. But if I talk about degrees, I'm really talking about the measure of the angle 1 and the measure. The measure is the degree. So if I add these two together, I should have 180 degrees. We're going to look more into that as we go along. And same thing with angle 2 and angle 4. Their measures are together, they add to 180 degrees. So let's quickly identify some vertical lines. Look at these three options below. Let me know if they're vertical angles, a linear pair, or neither. So for A, let's see what's so unique about A. I would say A1 and 2, they're next to each other, they're adjacent, right? And not only they're adjacent and their non-common sides are on the same line, meaning the red part for 1 and the black part for 2, they form one straight line. So because of that, they are linear pair. So 1 is linear angles. I'm sorry, linear pair. Okay. For B, look at B. It really doesn't fit in any of the criterias. They are, it looks to me that either they're not on the same plane if it's a 3-dimensional, or if it's a 2-dimensional, there's this line, if I have to draw this line, if it goes straight, that would make a different angle. But because it doesn't go straight, so 3 and 4 are not linear pair, nor are they vertical angles. So the answer is neither. Okay? And the third one, 5 and 6, we've got adjacent angles. They're not adjacent angles. They're not right next to each other. They're scissor angles, meaning they're vertical angles. They look like scissors. And their sides are formed by 2 intersecting lines. So 5 and 6 are vertical angles. Okay. Here's a postulate called linear pair postulate. If 2 angles form a linear pair, then they are supplementary. We actually already went through this. So what this means, what this tells me in math symbols, is that the measure of the first angle and the measure of the second angle would add up to 180 degrees if these 2 angles form a linear pair. So what that means is if we look at this purple angle here, if we call that 1, and then if we look at this gray part, and we call this gray angle 2, right here, from the purple line to the red line, that's angle 2. Notice that they form together between angle 1 and angle 2. They form a straight line. And the straight line is 180 degrees, and therefore we say that they are supplementary angles. They supplement each other. They're supplementary. Okay? So that's linear pair postulate. We also, here's a theorem that says vertical angles are congruent. So if we designate this angle here, the red angle, if the red part, this angle here, is 3, so then angle 1 and angle 3 would be congruent. Notice that angles are congruent, okay? And if I call this angle here 4, then my angle 2 and 4 would be congruent. So that's vertical angles, that's a theorem. Let's look at an example here. I want you to find the measure of RSU. So from RS to SU, that angle there. Now, if I know, it looks like angle RSU and angle TSU. These two are a linear pair, right? Because they form a straight line, a segment between RT, for example. So by the linear pair postulate, they are supplementary, meaning the measure of RSU plus the measure of TSU should equal 180 degrees. But I know that TSU right now is 62 degrees. So all I need to do is to subtract 62 degrees from 180. I should arrive at my final answer that the measure of the angle RSU is 180 minus 60 is 120, then a minus 2 is 118 degrees. That's how we do it. That's how we use the linear pair to find two angles adjacent to each other to form a line, and then we know that they form 180 degrees. That will help us solve more problems. Let's see how we use the vertical angles theorem. In this case, I'm asked to find the measure of CED. So CED is here, right here, this angle here. Now, I know that AEB, because this is a scissor angle, right? So my angle AEB is 50 degrees. And AEB and angle CED are congruent by the vertical angle theorem. So these two are congruent angles, and because of that, I know the measure for AEB should equal, notice it's equal when we talk about measure of CED. And we know the measure of AEB is 50 degrees. So if we just simply substitute it, we should draw the conclusion the measure of CED is 50 degrees. It's the same as the measure of AEB. Here's another example. Exactly the same approach. We need to find angle 1, 2, 3, but we're only given one angle. I always start with the vertical angles because scissor angles are easier. So by vertical angle theorem, we know that if we call this angle 4, so angle 2 and angle 4 would be congruent, right? That's the vertical angles theorem, meaning if I have a pair of vertical angles, if I have a pair of scissors, the vertical angles are congruent. And I know angle 4 is 35 degrees, therefore my measure for angle 2 should be 35 degrees as well. So I'm going to write the final answer for angle 2. The measure for angle 2 is 35. That's one answer we found. And then also, if I know that angle 1 and angle 4 are supplementary to each other, meaning the measure of angle 1 plus the measure of angle 4 should equal 180 degrees, right? Because linear pair means they're a straight line. And I know angle 4's measure is 35 degrees. So if I do the substitution here, if this is 35 degrees, if I subtract 35 from 180, I should have my answer. I'm going to write it on top. Measure for angle 1 is 180 minus 35. 180 minus 30 is 150. 150 minus an additional 5, I should have 145 degrees for angle 1. Now, if angle 1 is 135 degrees, I know that angle 1 and angle 3 are congruent because they are vertical angles by vertical angle theorem. And if angle 1 is 140 degrees, the measure of angle 3 should also be 145 degrees. So in a way, you're just looking around the angles and try to establish relationships between each angle and try to find an angle that you don't know and how it relates to the angle that you already know. If it's vertical angles, they're congruent, they have the same measures. If it's linear pair, they are supplementary, they add up to 180. That's really it. So finish this checkpoint practice. And this is our last example, I believe. Find the value of y. Notice that even though we're adding a layer of algebra with it, we still use the same theorems and postulate we learned in geometry. As soon as I see two intersecting lines, it's my scissor angle, it's my vertical angle. So by vertical angle theorem, the measure of this angle, let me use red, the measure of this angle, let me call this angle 1, and I'll call this angle 2. Okay, so my angle 1 and angle 2 should be congruent, which means that their measures should be exactly the same. So 4y minus 42 has to equal 2y. It has to equal 2y. Now, if I subtract 4y on each side, I would, on the left-hand side, I only have negative 2. On the right-hand side, I should have negative 2y, right? And if I divide now both sides by negative 2, I should end up with y equals 21. Now, let's see if we can verify if y equals 21, angle 1, the measure of angle 1 is 2y. So it's 2 times 21, and that I would have 42. Sorry, that 21 did not come out right. So I should have 2 times 21. Okay, now angle 2, measure of angle 2 is 4y, which is 4 times 21 minus 42. 4 times 21 is 84. 84 minus 42, I have 42 degrees as well. So if both angles came out with the same measures, it proves that they are vertical angles. Here's some additional checkpoints. I gave you the answers for this one. Make sure you know how to demonstrate step by step on either your scrap paper or your packet how you arrived at these answers. Okay, thank you guys. Bye.